right, in a way, yeah, or in another. So from that point of view, there's a few slides I would go pretty fast, and there's a few slides where I'm going to take a little bit more time because I think it's still a valuable addition to what has been said so far. So this one is, for instance, one of those which we don't need to talk too much about because we have seen it multiple times. The funny thing is always when I see this slide is, and I put it now here in this green and even dotted green, the bottom thing is, you know, we have such ambitious targets and we want to be 0 by 2050, and what we are saying is, yeah, it's depending on innovation. So it's good to be here and discussing this innovation. I think that's what the purpose of these conferences is, and I personally feel that we are coming a long way, and things are definitely developing, right? And one of those things, yeah, why we have this session now, Multifuel, is actually exactly related to this innovation, because then this one, we have seen it, Daniel Chatterjee showed it also, this beautiful slide, you know, all these measures which can be done to improve shipping. But we heard from everybody that at the end of the day, this is super important, but the most efficient, or let's say the most innovation needed in terms of what we are discussing here is this fuel issue, which is this green box where we have the immediate and the maximum effect on the emission, the greenhouse gas reductions. Okay, so alternative fuels and technologies at the end of the day, that's where it goes back to. And yeah, I always like this ship because it's some people are saying it's old technology already because LNG is one of those fuels that nobody wants because it's still fossil. On the other hand, we also all know that it's the only one which is literally available. It's a little bit out of fashion because of pricing issue right now in Europe, at least. But we can consider that this might be a temporary action. And even though it's a fossil fuel, it opens from a multi-fuel perspective also certain opportunities. And it's a vessel which has marked fundamental change in the industry. So I think it's an important milestone. The energy transition has many possibilities, and then I mean we use this in Bureau Veritas. We use this slide very much to show the different pathways. So I mean, obviously we are somewhere down here now in this LNG, oil, LPG. Even though if we would have ethanol or methanol available, typically it's not a greenish one. It's something in between. And we need to move upwards. And yeah, I like to actually also add things which not everybody is showing on those slides. Typically, what you are seeing is then the biofuels and the synthetic fuels, and then the basically the CO2 free fuels, which is hydrogen and ammonia. But actually, important is also this wind-assisted ship propulsion. From my point of view, one of the topics which is just discussed in the other room right now. It plays a fundamental role to increase the efficiency of the shipping as such. And at the end of the day, it is shortcutting. The wind-assisted propulsion is shortcutting the whole conversion we are discussing with these e-fuels. You know, take the wind instead of putting it through a windmill and the whole process into an e-fuel. Just take it to propel the ship. Yeah, so it's absolutely a valid path to go. And another one which is gaining, from my perspective, or will gain traction, is the carbon capture, or let's say the partial carbon capture and storage, because obviously, for obvious reason, it seems to be pretty unlikely that the whole carbon which is coming out on a ship propulsion, at least if you look at diesel fuels, can be captured from a volume perspective. But it has a role to play when it comes to optimize the lifetime of existing tonnages, which going to be having challenges with the CII in the coming years. So from that point of view, we shouldn't underestimate the dynamics which might be happening on that side, because it's going to be driven by by financial issues. It's going to be driven by practical issues to keep the fleet afloat and to keep the fleet running under the circumstances, a regulatory framework which is somehow put up. So in that respect, there's a lot of pathways to these decarbonization, or to transfer the shipping into the low carbon shipping industry, and all these are valid pathways. But the question here is now, many people dream of these multi-fuel. So it should be a multi-fuel thing. So basically, I imagine under multi-fuel, I was thinking about a ship where you basically put in any fuel, whatever it is, and the ship is just running with it. So it's a push button, or even maybe it's self-recognizing that today I have ammonia, and in 3 weeks' time I have methanol in the tank, and then everything is adapting to it, and it's a multi-fuel, so it can do everything. And we as engineers, we know that most likely it's not going to happen like this. And this is because there are so many considerations to be made here. I mean, there are all these physical, chemical properties which are so fundamentally different, specific energy, density, weight and volume, gaseous, liquid, cryogenic, ignitability is fundamentally different. We saw that very nicely in the last session about the perfect fuel for low-speed engines being ammonia, which is so slow. Interesting. Safety aspects, toxicity, and so on and so on. There is also the question about which converter is really the best one then to run. I mean, I'm not seeing a hydrogen-driven low-speed two-stroke engine most likely in the foreseeable future. So this multi-fuel is very nice, but it seems to be rather unlikely in this respect. But okay, that's for combustion engines, the internal combustion engines. There's also fuel cells available, maybe in the future, which needs to be looked at, and maybe something we haven't been thinking out for yet. But I think the most important will be the availability and the cost at the end of the day, which needs to be considered when we look at where the voyage going to go regarding the fuel, and their availability and cost is related not only on a global thing but also on a regional thing. There are regional opportunities. Very nicely, the project Orca, which won yesterday the prize. This is possible today in this environment. Drop-in capability is actually something I believe is fundamental important. If we have fuels with a drop-in capability, we can achieve a much higher level of decarbonization fast than if we need to change technology, retrofit, and go those parts. And for sure, the regulatory framework needs to be looked at. Okay, we don't need to discuss too much about this one because it has been very nicely presented in the last panel. Multi-fuel with internal combustion engine. Actually, there's a high level of fuel flexibility with these famous two Otto and diesel cycle available for the internal combustion engines. And but on the other hand, we also know that the basic parameters, fuel injection equipment, as well as everything which is related to emissions, are fundamentally different when you talk about these different fuels: methanol, ammonia, LPG, ethylene, LNG, and so on and so on. So even though the internal combustion engine can do it, but to do it within the similar engine, it's rather a big challenge. I have drawn, and this is on my experience only here, a bit of a map. What is actually available for which fuel, which engine technology, and I have actually split it in fast running, or fast or medium speed running four-stroke engine, and the low-speed engines, and then mapping it with the different fuels. And what you can see here is that actually, yes, this ammonia, we discussed it before, is actually still missing. It's worked on, but it's not available. And there is also some other topics which are not available. So internal combustion engine, multi-fuel capabilities, yes, theoretically, but practically, it's a much more of a concern. And we have to consider it's not only about the engine as such, it's also about the whole fuel supply system. And there we heard also the level of complexity when you deal with different fuels, ammonia, toxicity, methanol, corrosion issues. So it needs to be considered very careful, LNG cryogenic. So last but not least, we can say that there is a lot of technologies available, but it is very difficult. We don't have this multi-fuel thing where a ship can automatically run on different fuels without any major work to be done. How does it looks on a fuel cell? And I found it actually quite interesting that the fuel cell has actually a higher level of let's say, certain multi-fuel flexibility, because actually you are having always a kind of a chemical reformer before, or a reformer, and finally you are using the hydrogen which is coming out of either methanol or ammonia, which is today used, or you can also use CH4, methane, reform it in a reforming process and apply it to the fuel cell. So fuel cells are actually rather multi-fuel capable. You just need to adapt the process in front of it to make it suitable for different variety of fuel supply. Okay, so we come back to all these properties. These are the things which needs to be considered, and that's what plays a role when you look at how complex and how easy is it to apply certain fuels into ships. We don't need to go into that because you know it. I just wanted to show, and I made actually out of it a bit of an estimate how complex it is to do certain ships with something. So every time it goes back to this basic physics here, and the complexity to build and to operate. And now I'm looking at ocean-going ships, so bigger tonnage, longer trips, a lot of cargo. I try to symbolize how complex it is and how expensive it is to build and to operate. So methanol is obviously pretty achievable to do. I mean, on the very bottom left side, you would have the conventional diesel engine. Methanol, CCS is actually also, it's just an additional equipment like a double scrubber, more or less, a bit more complex, but anyway, it can be added. LNG, we know it very well, but it's rather complex. Cryogenic, blah, blah, blah. What kind of tanks, membrane technologies, and so on, pressurized tanks. So it's known technology, but it's complex. Ammonia for sure is going to be more complex than LNG because you have, in addition, the toxicity, and you have all these issues to deal about around that one. And if you look at H2, it would be even more complicated because I think for ocean-going ships, the only way would be liquefied hydrogen, and liquefied hydrogen is minus 262 degrees, and we all know it's literally a big challenge to go that path. But if you look at how would it be to retrofit existing ships, and I think it's not so much different here. The easiest thing when we look at the existing tonnage is on one hand side the CCS for a partial carbon capture, and for sure the methanol seems to be the easiest way. Engines are easy to retrofit or possible to retrofit. We have been seeing the solution prepared by Wärtsilä Services. We have seen already conversions out there. The technology is known. The fuel specification is rather easy to deal with. Much more complicated will be ammonia, LNG, and hydrogen. If you look at small and coastal ships, and I think then the picture turns completely, because small coastal, depending on how small it is, electricity come actually in as a very handy solution. We might have the possibility to build and operate easily methanol small tonnage, CCS and H2. H2 in this hydrogen in this respect would be then pressurized hydrogen, and then it's more easy, or metal hydride storage solutions for the hydrogen. Then it would be much more easy to install it. Retrofitting small ships to LNG on ammonia, highly building highly complex. I think we're not going to see that. And if we look now at the retrofit possibilities, here I think methanol will be again one of these most achievable solutions. Electricity and hydrogen can be done as long as the ship is having already a kind of diesel-electric hybrided solution. So I think for smaller tonnage, that's absolutely a way to go. And finally, LNG and ammonia, not likely to happen. So have you seen actually the study made by the McKinney-Møller Center about the retrofitting of a container ship to different fuels? I have put here the results into the pictures. They have been making estimates for a diesel engine or a diesel fueled ship or an LNG fueled ship to retrofit either to ammonia or to methanol. And they have basically concluded, going through the thing, that if you would retrofit a diesel ship, you would invest an equivalent of 16.5 to 24 million, or 11 to 16% of the new building price. It was 15,000 KTU. If you retrofit it to ammonia, it would be up to 24% to retrofit a diesel fueled ship. If you take an LNG fueled ship, retrofit to ammonia, still 15%. Actually, what I was missing in this study was that what would it be if you would not run on methanol and ammonia, but on e-methane? This would be the cheapest way and most likely the most likely way for this kind of application. Okay. What we will get will depend at the end of the day on the cost of the fuel, and the cost of the fuel will depend on the efficiency to produce it. Up to here, the e-hydrogen, for every fuel, it's going to be the same efficiency, roughly 67%. And then you have the process, methanization, Haber-Bosch, you have the synthesis to methanol, or you have the Fischer-Tropsch to e-liquid fuels. So the efficiency is going down in this direction. Ammonia is the most efficient, Haber-Bosch is the most efficient process. And then you have a transportation efficiency, and last but not least, you would have actually a kind of a remaining energy. I think Dr. Chatterjee showed that very nicely this morning. And looking at that, we have to conclude that most likely ammonia has a role to play going forward in this game. That's absolutely clear. You will find that this study actually, or this slide as well, in this study prepared by Bureau Veritas on new fuels. And that one you find there as well, because we have been evaluating on the CO2 greenhouse gas story. That's where we are with the diesel fueled engines. The biofuels are somewhere there, and the e-fuels are really down here, which which is a conclusion important to see also, that the biofuels have a role to play on a short and midterm to start with, because they might be the ones available first. Okay, rule notes are available. Not only from us, from BV, but also from all the other classification guidelines are under development. It will be possible to design and build the ships. And for sure, there's a lot of activities going on. We have a lot of wind-assisted propulsion projects. LNG as fuel is definitely a big day-to-day business already today, and also for ammonia and for methanol projects are going on. More innovations are in the pipeline, and we will see them coming very soon. So as a conclusion, multi-fuel engine development will support later adaptation for these carbon neutral fuels. Complexity and cost of the retrofits might be higher than anticipated. I think some people dreaming that it will be very easy, but it's going to be more complex in the detail. And the exhaust gas after treatment, which might be needed, changing the fuel, needs to be considered as well. Onboard storage, yeah, all these things have to be considered. And I come back to my point that carbon neutral fuel, I mean, the drop-in capability is an absolute important topic to accelerate decarbonization of shipping, because then you can reach much more of existing tonnage. So sorry taking so long, but this is what unites us here today. Decarbonization of shipping, that's what we want to achieve. Thank you.
Thank you all for taking us through all the complexities of multi-fuel, which seems to be really multi-fuels when it comes to the decision-making process more than actually the operation of a ship. More about multi-fuel engines, the main cornerstone of a successful fuel transition. Michael Art, could you please take the floor and tell us more about that?
Good afternoon. My name is Michael Arts. I'm from Wärtsilä, and I have a few slides to share with you our vision on the decarbonization journey. And if we just look at the initial screen here, this rolling wave is perhaps a good metaphor for the challenges that our industry is facing. So just like the surfers that are riding these waves and are adapting constantly to the changing wave, also our industry is facing our challenges. Climate change and the regulation coming towards us, but also the geopolitical tension means that we constantly need to adapt. And I think that the challenges are there very much the same way and how we deal with that. This presentation is about the question, is the multi-fuel engine the main cornerstone of a successful fuel transition? At Wärtsilä, we believe this is the case, and I will take you now through the slides to show you what our argumentation is for that. And just like my predecessor, I will try to stay away from topics that are already well covered and stay away from too much detail on that. Just a quick look at the need. Of course, climate change is the result of the greenhouse gas emission, and shipping is contributing roughly 1 billion ton into that. The IMO has the greenhouse gas strategy. The EU has the Fit for 55 program. We see the Poseidon principles. We see the Sea Cargo Charter. So from the financing and the cargo owner side, there is also a demand to decarbonize. How we are going to deal with that will be largely based on decarbonization of the powertrain, so energy efficiency, and of course engines capable of running with net zero fuels. The reduction of energy consumption to begin with, so energy efficiency and savings there, and of course the optimization of the logistics chain, so the correct use of ship cargo capacity, just-in-time arrival, all those things matter and are kind of considered low-hanging fruit here. Wärtsilä's role in this transition is that we believe we should build future-proof powertrains, so engines and propulsion equipment capable of running on carbon neutral or net zero fuels, a wide portfolio of energy saving solutions, obviously life cycle services, so keeping engine and equipment in tip-top shape or retrofitting throughout the life cycle to be running with a different fuel set. And of course, our digital solutions, such as fleet operation solutions to optimize the routing of ships. This slide here is showing a picture of the fuel landscape. It is clear that we are moving from a single fuel industry to a multi-fuel industry. And how fast this will go and how much time it will take, time will tell, but it is clear that we are looking at an industry where we have multiple fuels side by side available. Ship owners that need to develop a strategy how they are going to transit through this journey and which fuels they can get and of course how they can run with that. At the same time, going through this transition, we see that there are many factors that impact the availability of fuels and which fuels they can get. Geopolitical events, for example. We see that the war in the Ukraine, apart from, of course, the human tragedy, has a big impact, of course, on the energy prices and the LNG price, which can be felt worldwide. There are trade tensions between the East and the West that could put a spanner into the fuel matrix. There are, of course, regional and seasonal differences which have an impact on the supply of biomass from which biofuels can be produced, or the availability of green electricity. And then, of course, there is the fact that zero carbon fuels, they don't exist. Everything has to be produced. And it was also touched by the gentleman from Rolls-Royce earlier today, the amount of electricity needed to produce zero carbon fuels, which all start by creating green hydrogen, which is coming from green electricity. So in this case, this picture, as I said, is coming from DNV on their maritime forecast. If we would have to produce 6 exajoules of green zero carbon fuels, only the amount of hydrogen needed to produce this, does anybody in the room know how much electricity would be needed? A best guess perhaps would be a hell of a lot, but if we would use 50 to 60% electrolyzer efficiency, we are looking at 3,000 terawatt hours. And just to put that a little bit in perspective, the Dogger Bank wind farm, which is built in the North Sea off the coast of the UK, is going to produce roughly 18 terawatt hours of electricity per year. So that gives you an order of magnitude how much electricity is needed for synthetic fuels. So that will mean that the reliance on LNG and biofuels will remain for quite a while, and we will need massive scale to make this happen. This here is a picture also from DNV-GL, and it is clear for us that alternative fuel production and availability will happen around the main shipping lanes. This is the status of today, and our message is that as a cornerstone one, ship owners, they need to develop a strategy on what fuels they can get in the area they're operating their ships. That's going to be the first item that ship owners need to have to look at in order to navigate through this transition. Obviously, the future fuel supply system also needs to accommodate that. So going from fossil liquid or gas fuels to a renewable mix up until 100% renewable, but instantly being capable of going back to fossil-based fuels in case there is some kind of breakdown or when the renewable fuels are not available. That's going to be essential. And obviously the automation and safety systems need to accommodate and need to make that happen. In the end, it is safety, reliability, and efficiency that will be needed from the system suppliers. On this slide, enough has been said. I think we are all aware of the challenges that each and every fuel candidate pose. Obviously, the fuel price factor is an estimation on this slide, and the estimations can have a big scale on going from cheap to very expensive, but that it will be much more expensive than what we are used to today, that is crystal clear. But for myself, the big elephant here is that the sheer volume that future fuels require is also something to take into account. And that brings me to the second cornerstone of this presentation. Ship owners, they need to develop on how to handle and particularly store the fuels on board. And you could put it perhaps in a different daylight, that how much cargo space can you sacrifice to carry sufficient fuel for your transportation on board. And now, since we know that the development of infrastructure and availability of green fuels needs time to mature, we have to look at the energy converter. The multi-fuel engine is the ideal energy converter in our case, in our view, and there are two basic reasons for that. First of all, we have to look at the technical feasibility. The internal combustion engine as a multi-fuel engine allows a gradual fuel transition. It can be used as a drop-in blending up until 100% pure, but also being able to instantly go back when fuel is not available or when there is a technical issue. If we look at the economic viability, the multi-fuel engine delivers the best total cost of ownership when running with future fuels. It has a vessel-long lifespan and it can be upgraded. Wärtsilä is developing a lot of solutions to upgrade existing engines and existing vessels to perform better, reduce their emissions, be more economic to run. At the same time, the internal combustion engine also combines high power density with high efficiency, and the operational flexibility and the conversion potential is almost embedded in the design. If we look at the future fuel candidates, methanol, ammonia, and hydrogen, all of these fuel types are in our R&D pipeline. So we are developing engine solutions to be capable of running with these fuels. And as already mentioned, since 2015, we have experience with methanol in the Stena Germanica, which was a conversion project. And in 2023, we have the delivery of our Wärtsilä 32 methanol engines. Those were contracted this year. You can see that on the right for the Van Noord wind farm project. And these engines come with a complete fuel processing supply system. When it comes to ammonia, as already mentioned in the previous session, we also have that in development. And in 2023, we have the sales release of our first new build engines capable of running on ammonia. And when we look at hydrogen, there our developments are concentrated on engines used in the energy business domain. We believe that hydrogen as a fuel in the energy business has a very high potential, but in shipping, especially deep sea shipping, where you need to liquefy hydrogen to have sufficient energy content on board, we think that the role of hydrogen is going to be small. However, if the market demand is there and we have the technology available, we're always able to bring it to the maritime world. And here on the right, we see a couple of the engine launches that we had in 2023, with on the top the Wärtsilä 46 TSDF. This is a two-stage turbocharging 46 engine. It is setting a new benchmark in efficiency and minimization of emissions. There is a nice order in the book for Royal Caribbean for a large cruise vessel they are building. Below that, the Wärtsilä 32 methanol with the reference for the Van Noord wind farm project. And at the bottom, our small bore engine, Wärtsilä 25 DF, which is also setting a new benchmark when it comes to efficiency and minimization of emission. And this engine is also modular and built up, so it is ready to be converted to be running with a different fuel. And this brings me to the third cornerstone, that ship owners that select a multi-fuel engine have the capability to be flexible and adapt to a changing fuel situation whenever they want to or whenever they need to. The key takeaways from this presentation is that fuel availability is key. Future fuel storage is key to embed that in the vessel design. And the multi-fuel engine offers you flexibility in blending and backup. And that allows you to have a safe, controlled fuel transition towards a decarbonized world. Thank you for listening, ladies and gentlemen.
Thank you, Michael. We now head into the lubricants parts of this session about alternative fuels preparing for the impact on marine lubricants. Harriet, please.
Hello, my name's Harriet Bryce and I'm here on behalf of Lubrizol, and we provide lubricant additive solutions for various transportation and industrial end uses. And my role focuses on the development of new additive solutions for marine engine oils. So I'm pleased to be here to discuss lubricants in the context of future fuels and highlight the importance of lubricants as part of a successful strategy in utilising alternative fuels. So lubricants play an important role in the safe, reliable and efficient operation of engines, and they do this through the lubrication of moving parts, keeping the engine clean and free of deposits, and also through neutralisation of acidic combustion products. And they're doing this at the interface of the hardware and the fuels. And as we've heard over the last couple of days, each of these fuels has differing physical and chemical properties that present specific challenges to the engine, cylinder condition, and also potential for interaction with the lubricants. So we can't overlook this, and we need to study these impacts so that we can design new lubricants that will continue to provide the same level of performance as we do with conventional fuels. So our process and approach to this is to look at the inherent characteristics of each of the fuels in terms of those chemical and physical properties. We also seek to understand the adaptations to the engines and hardware components that are required for each of the fuels. We also look at the operational impacts, and this encompasses the combustion processes in terms of temperatures and pressures, and also the mix of combustion products that might be produced. And then this enables us to put together a framework of lubricant requirements for each of those specific fuels. And ideally, this would be done in parallel with the engine design process, so that we can be ready with a lubricant solution when those engines go to market. So I'll talk in depth about each of these fuels on the left-hand side a little bit more. When LNG engines entered the market around 2015, 2016, the lubricant selection was based primarily on the low sulfur aspect of LNG. But the challenge really came from the combustion conditions, and LNG combusts at higher temperatures. And so the lubricant selected didn't have the sufficient thermal robustness and cleaning ability to keep the engine clean. Since then, development of the lubricants has moved on so that we can provide high-performing lubricants with the right level of thermal robustness and cleaning ability, and these are the ideal solution for use with LNG. For methanol, our testing highlighted the potential for interaction with the lubricant and formation of emulsions. So you can see an image on the right-hand side. With methanol, you get this hazy appearance, and it's these emulsions that potentially can block filters and pumps, but also can disrupt the actual lubricant performance in terms of providing a suitable wear, film and protection. So yeah, there's a concern around increased wear that could occur. However, there are a number of engines in use with methanol today, so there is service experience that suggests that current lubricants do provide sufficient performance, but I don't think it's quite that clear. And as engine designs evolve and also methanol becomes more widely used in different vessel types, with different operational profiles, there could still be a concern around lubrication aspects. So when thinking about lubricant requirements, it's important to again think about the cleaning ability, wear protection, and demulsification aspects to handle methanol. The interest in biofuels for marine has been increasing over the last 6 months to a year, with an increasing number of trials being carried out. Biofuel is being viewed as a drop-in fuel, but we think it poses potential challenges again to the engine lubricant performance. And this comes from our experience with the introduction of biofuels for automotive applications, where we saw increased oil oxidation, piston deposits, and sludge formation. And this is through fuel dilution of the biofuel into the lubricant. So over time, levels of biofuel can increase in the lubricant, and this drives those oxidative processes. And this is demonstrated by the testing on the right-hand side that we've done here, where we took a lubricant and contaminated it with ultra-low sulfur diesel and also the same amount of biofuel. And you can see the lubricant with the biofuel contamination leads to increased deposit formation over the course of the test. And with the increased levels of renewable content that are being looked at for marine, the lubricant's more at risk of these oxidative degradation processes. And some of these processes can take a long time to occur. And with the relative short duration of the trials that have been conducted, and also these have focused more on the operational aspects of using biofuel rather than looking at the lubricant condition, We can think that the long-term impact of using biofuels for marine is unclear, but with improved oxidation in deposit control lubricants, we think these would be a good solution for use with biofuel applications. And finally, ammonia. So ammonia, we know, has some unique characteristics, and we've heard as well the safety implications of using ammonia, but I can't go without not mentioning the processes that we had to go through, risk assessments, in order to be able to test with ammonia in our laboratories, but also the handling of ammonia contaminated lubricants. So this can't be underestimated when approaching testing with ammonia. I'm going to talk a bit about the corrosive effects of ammonia and also some lubricant compatibility testing that we have done. But whilst we can do a lot of testing in the laboratory, until a two-stroke engine is combusting ammonia, we can't study the impacts of combustion or the mix of combustion products in more detail, so that will come later. So the corrosive effects of ammonia are well documented in the literature, particularly for metals such as copper and copper-containing alloys, some of which are used in marine engines today. So I've presented here some of the results with the copper coupons that we tested in a vapor phase ammonia environment and also with ammonia contaminated lubricants. So you can see in the top table, the effect of ammonia on corrosion is dramatic. You get this very intense colour change, and also it can leach copper into the solutions. So to test if lubricants can provide some protection against this, we looked at a base oil with no additives in it, and also a fully formulated lubricant. And this was to see if just a barrier to the ammonia environment would be enough to protect against corrosion, but it showed that it wasn't. But with a fully formulated lubricant, we can deliver protection against the corrosive effects of ammonia. So in the bottom table, this was where we looked at the effect of ammonia contaminated lubricant. So the lubricant was pre-contaminated with the ammonia, and then the copper was left in that solution for a period of time. And the key result that we found here was when you introduce high temperatures, and we saw differentiation between different lubricants. So it's showing that lubricants can offer protection against the corrosive effects of ammonia, but it also depends on the lubricant formulation that is selected. So the lower performing lubricant here still allowed some corrosion of the copper to take place, whereas the higher performing lubricant looks very similar to the start of test piece. And then we considered the compatibility of the ammonia with the lubricants itself. And this is centered around the fact that ammonia solubility with mineral oils and hydrocarbon lubricants increases with temperature and pressure. So within the combustion environment, there is high potential for ammonia to solubilize in the lubricant. And what we can see from the images at the bottom here, which is two different lubricant formulations, some of the lubricants have a tendency to react with the ammonia. And we can see that occurring here for lubricant 4. So before exposure to ammonia, it's nice and clear. And after exposure to ammonia, it's taken on this hazy appearance, which shows that it's undergone a reaction with ammonia. And the implications of this are on lubricant performance. So if the additives are reacting with the ammonia, they're not going to be available to deliver the performance that they're intended to. But also the products of those reactions could have impacts on stability and also form deposits themselves, which is not the intended result. So the summary for the ammonia is engines operating on ammonia are likely going to need different lubricants to ensure compatibility, but also to provide the corrosion protection if those types of copper-containing metals cannot be removed. The impact of the combustion conditions, again, we've said we can't fully study that until we understand more about the combustion conditions, so that will follow. But and that could introduce more different requirements for the ammonia lubricants. But the anticipated lubricant requirements we see is, again, the corrosion handling could be important, engine cleanliness, and also acid neutralization. But generally, the ammonias continue to be evolving knowledge space for the lubricant aspect. So just in terms of overall summary on the alternative fuels, we've heard over the last couple of days again about the different characteristics of these individual fuels and the specific challenges that they pose to the engines. And we've shown some of those challenges that they also pose to the lubricants. And so we think some of the alternate fuels will likely require new lubricant solutions. But I want you to take away from this and remember that lubricant selection is important, and the right lubricant selection will be key to a successful strategy in utilising alternative fuels. Thank you for listening.
Thank you, Harriet, very much for reminding us that lubricants are never an easy subject when it comes to engines on ships, and especially not when we get into the new fuel areas. The last session today, or the last presentation, is about what will a multi-fuel, low-carbon future look like. Eddie from ExxonMobil will tell us more about that.
Thank you very much. Good afternoon, everybody. Thankfully, some of you are still in the room. I appreciate that I'm standing between you and seeing your loved ones. But what I've seen over the last sort of day and a half, 2 days, is there's an awful lot of love in the room, not quite in the same way for love as our family, with our family, but certainly love for the industry. So I'm going to spend the next few minutes covering some information, some material that you have seen before. So I will be going through this pretty quickly, but just trying to give you a few examples, a few numbers as to how I and ExxonMobil, see some of the challenge that lies ahead of us. For the lawyers in the room, that's the most exciting slide. For everybody else, let's move on as fast as we possibly can. We've heard IMO setting the rules, setting the landscape and the position forward. That's certainly ExxonMobil's view, to have clear and concise and consistent messaging, so that the ships, our business, they're moving all around the world. That doesn't mean to say what the European Union is trying to achieve, and perhaps trying to encourage IMO to accelerate some of its ambitions. That doesn't mean to say that that's all in vain. But if we have different legislation in different parts of the world, it will not be quite as smooth as we need it to be. If we look at the successes of IMO 2020, there was a fixed date in mind, and we did a pretty successful job of achieving what we needed to achieve. We should be proud of ourselves, but we can't just keep looking over our shoulder and celebrating the past successes. We need, of course, to really look forward. One of the big challenges that we face, and this isn't just a marine challenge, this is a society challenge. And the best way I can describe it is it's a dual challenge. The population is going to increase to about 9 billion by 2040. The demand for energy continues to increase, not just with that population increase, but the developing world wanting to become developed. There are still about 1 billion people that don't have access to regular electricity. And so we saw from some of my colleagues on the panel just earlier, the increased energy demand just to produce, say, hydrogen is massive. But that's, even if you sort of just take that out of the equation for a moment as well, the world's energy demand is going to increase hugely. So that's one part of the challenge. The other part of the challenge is how can we do things in order to better appreciate the challenge that we're facing to the climate right now as well. So we need to understand and appreciate the climate change that's also happening. So that really is the big challenge. And of course, you know, we take a look at what we're doing internally. We need to get our own shop in order. You know, I'm the fossil guy, you know, that people have been talking about as well. And again, I can't just rest on 150 years of company history. We need to change. We need to make significant changes and improvements, not only to look after ourselves. We're not doing this just from a selfish standpoint, but for society as a whole. This slide is your competition. I know we all think that marine is the center of our universe, but it's not all about marine. Sure, 90% of the goods at some point in their life cycle are transported with our business in mind. But the other hard to decarbonize sectors that you see there are the power generation, industrial, and transportation. And we are still just one part of that transportation need. So there is quite a challenge. If we just, you know, focus into just specifically on the transportation side, we've heard, you know, about batteries. That will work in certain sectors. Some of the short sea shipping, if you're near, will potentially work. I think I've also heard at another event that for deep sea or for vessels tramping around the world, one vessel powered by batteries, you'd need 3 or 4 other vessels just with the battery packs in order to support that as well. So that won't work everywhere. We've heard about some of the other alternatives. Again, I think we've done an awful lot of talking about some of those alternatives going forward as well. But what sort of ExxonMobil sort of believes in, and I'll just sort of skip this slide, is, you know, what do we really need to consider when we look at those future fuels? Of course, meeting industry's needs, following IMO's ambitions, I think by now these are all of our ambitions and what we really need to do. Supported by clear and consistent legislation. If that's not done in order to equalize perhaps some of the pricing. We've been very fortunate in marine because the conventional fuel, heavy fuel oil that we have been burning for decades now is actually cheaper than the price of the crude oil that goes into the refiner in the first place. So as a consequence, we've been paying pretty cheap prices for a very energy dense product to move our vessels around the world. That in itself will have to change. And if we just think back to that competition slide, the power generation, industrial uses, manufacturing as well, are willing and are currently paying a lot more for their energy than we are on the shipping side. So I think all of us in this room need to understand and appreciate that energy is going to cost us more. The infrastructure needs to exist. We've heard a lot about some products are currently in the marketplace. Some, such as ammonia, is still readily traded around the world as well, but that bunker infrastructure isn't in place. And of course, we've heard very much about from the equipment builders what's needed to be done there. Some of the alternatives going forward are slightly less capex intensive. Biofuels, for example, are drop-in, so no real need for expensive equipment. Whereas LNG, some of the others, you'll need to invest more in on the capex side. Availability across the ports, the products need to be scalable, so we need to take it from lab development to being able to produce it into those ports at the right sort of levels. And because we're carrying 90% of the goods around, these products need to be reliable. The supply chain also needs to be reliable. I couldn't come to this event without putting a graph up, so I hope you'll forgive me. I'm not a sort of chemist by profession as well, but here's the standard chart for you. But what I want to sort of highlight here, and certainly ExxonMobil very much believes that hydrogen is one of the, if not the molecule of the future as well. A lot of talk has been about the green products, the renewables as well. But don't forget blue. A lot of what ExxonMobil will be producing from a hydrogen standpoint is going to be blue hydrogen. So that's producing it, but with carbon capture. And I'll talk about the carbon capture in a bit as well. So blue is going to be probably more readily available, more quickly. It will provide just as good sort of net zero benefits with the carbon capture as well, but it will also be cheaper. And what I also want I'm certainly trying to do this as well. We've been buying marine fuels in dollars per ton. I think now what we need to be looking at is dollars, so the price per energy value, because then that builds in the energy density equations that we've been hearing about. You know, LNG 1.6 times that of a conventional fuel, and 2 or 3 times the storage even higher needed going forward. So we should do those cost comparisons on an energy versus an energy unit. They say that, you know, if you see something 3 times, it'll stick. This is probably the 3rd or perhaps even the 4th time we've looked at these comparisons. It is going to be in the handout material. I don't really need to say much more about it as well. I'm sure many of you in the room have got preferences going forward. In the press, you'll see that some of the bigger sort of container lines are very sort of happily supporting LNG right now, as well as biofuels, because that's the here and now. But then going forward, some are backing the methanol horse, some are backing the ammonia horse as well. So it really comes down to a vessel by vessel decision. And we are being asked a lot of questions about what are you going to have? You know, when are you going to have ammonia available? Where will it be? Can we have it in Rotterdam? What's it going to cost? And then, of course, we go back and say, well, what's the demand going to be? So trying to get out of that chicken and the egg position by actually making it clear how we as ExxonMobil, you know, certainly see the future. And this is a pretty good sort of way to summarize it. So we certainly believe hydrogen is the molecule of the future, but along with the carbon capture and storage and sequestration. As a corporation, we have captured more carbon and stored and sequestered that carbon than anybody else in the world combined. So ExxonMobil just as one company based in our operations over the last 10, 20 years. We need to do this. We're a pretty energy intense industry ourselves, but that's just a start. We've got 10 projects around the world that are going to further develop those carbon capture and sequestration projects. And they've already started. So it's not just talk and no trousers. It's actually, you know, it's really starting to happen right now. We're also looking at hydrogen hubs. That is, as we've heard repeatedly, one of the molecule of the future. It's not cheap to build a hydrogen hub. And we're not only producing these hydrogen hubs for our own benefit, for our own operations. We currently produce 1.3 million tons worth of hydrogen. That's part of the refining process to help you produce diesel, go into chemicals products as well. So we already are a significant player and have significant knowledge around around hydrogen. But we're talking major hubs. Baytown on the US Gulf Coast, working, again, not only for ourselves, it's a big industrial area, a very high energy intense area. So that's going to be for those businesses as well. And we're looking to capture the carbon, which is quite fortunate because then it's quite easy to sink that carbon back into the ground as well. We're also talking about projects happening in the Solent, so Southampton on the south coast of the UK. Again, it's a $3 billion type project that you need to have long-term commitments in order to invest that sort of cash as well. But to support the local industries, that will then also give us the potential access for those molecules to come into marine, potentially as methanol, potentially as ammonia. We've also done elsewhere a couple of examples. Slagen up in Norway used to be a refinery. We've converted that to a terminal. We've signed an MOU with a couple of other partners there. That'll be producing 20,000 tons worth of green hydrogen, and also potentially 100,000 tons worth of ammonia storage for distribution there in the Oslo area. So we are putting our money where our mouth is. I won't talk about lubricants. I think Harriet did a fantastic job of lubes, but we can't do this alone. Not only just talking to you here, we're talking to an awful lot of other extremely clever people as well. So not only the partnership, the MMMCs, the Getting to Zeros, the MIDCs, the OGCIs, lots of acronyms there, but for many of the organizations with whom we are collaborating. But it's actually reaching out and going to some of the educational institutions as well. Just as a little bit of an aside example, designing the car of the future, designing the car from 2035. You would think you'd go to the car manufacturers. but they're pretty set in their ways about what they believe, the future car to look like. So by going to sort of students and using it as some projects as well, if you get the opportunity, have a look at, I think it's called Project Orange 11 online. So some students from in one of the Texas universities have designed a car there using lightweight plastics. A lot of what we're doing is shifting heavy products around the world in whatever form of transportation. So the more lightweight you can make a vehicle, that could also be, practical for shipping in the future as well. Why we're using such heavy, of course, solid materials as well. But that doesn't mean to say that plastics can't also be used in that space as well. So it's all about thinking, collaborating more broadly, because we won't be able to, again, just fix it together. And we may be taking decisions or going along a certain route because of the biases that have been formed in our times with our companies. I'm sure I've got some marine bias after 30 years in the company as well. Getting new ideas, new people in will certainly help us going forward. So the last summary slide really for me. We are a big, pretty sizable corporation. We've also committed to spending a lot of money with a new business that we've just set up called our Low Carbon Solutions business. So it's slightly separate for the business, but we've got $15 billion earmarked to invest over the next 5 years. That perhaps seems a lot. If you think that a hydrogen project is close to $2 to $3 billion, again, huge numbers, and I'm not talking these lightly because we still have to go through the understanding of, yes, we are responsible to not only the world, but also to our shareholders in that order, actually, as well. So we do need to spend the money wisely, but we also need to consider that this investment is needed, not only for our own existence, but for the greater good for the community going forward as well. So thank you very much.
Thank you very much, Eddie, for a, may I say, reality check on what is ahead of us in this decarbonization discussion, which easily becomes, slightly rose in when you really discuss the individual solutions. But the bigger picture is the one that needs to be solved, and the bigger picture requires a lot to be done. We shall have a Q&A session, and as usual, Slido is open for you to post your questions, if you have any. I hope you have, else we will run out of, I think, my imagination here for what I could ask about. It's an interesting aspect, I think, and what has been presented here to really take us a little bit back, to be a little bit more realistic about what all this multi-fuel future means and so forth. And I think that has been really helpful to remember that it's a lot about a multitude of avenues where you need to make decisions to actually put some hardware in place on a ship that is probably not a multi-hardware when it comes down to the actual thing. It's a little bit like the cars. It's either electrical, maybe it's hybrid, but you choose also the engine technology there when you buy the car. But you have options, of course, which is good for the decision process to be made. Also, I think on the lubricant thing, a good reminder that we need to remember that as always, there is classical challenges with operating engines out there in the marine environment. We saw that with the 2020 low sulfur fuel requirement. Suddenly there were a lot of lubricant issues. We will have more lubricant issues when we move into these new fuels. The good thing is that at least some of the solution providers, they are ready, at least in their preparations for whatever problems we will see. But I guess we will also in this new world see a lot of new problems that we have never even thought about. And as you can see, I'm kind of treading water here a little bit, swimming around because the Slido is still empty. It is late in the day. So
You do a great job.
thank you.
Go on for some.
No, but I'm thinking the panel is has been it's been a very different panel than the earlier panels, and maybe you could challenge each other a little bit. Also, with what you heard, is that too much to ask? So while you think about that, and I look at the audience, and everything seems to be clear. So anything you want to say as a final statement, or having listened to the other presentations in this panel? Who wants to start?
I'll give it a shot. Actually, I think it was one of the questions that came up yesterday was how can you make vessels more efficient? How can you sort of save money? And not wanting to plug just what ExxonMobil does, but there are some lubricants. If you think about the whole ship, not only the engines as well, but a lot of the other aspects of the vessel. If you've got hydraulics, use synthetic lubricants that last longer. They're less wasteful, but you can also get energy efficiency savings from them as well. You can get 4, 7, 8% efficiency savings. So if you're responsible for that, consider your greases and other aspects, your hydraulics. So don't only think engine oils. There are synthetic products there that have got proven energy efficiency savings as well.
Thank you.
We should challenge each other. So actually,
Microphone.
I would like to challenge you a little bit. I mean, the elephant in the room is the availability of these new fuels. Obviously, we discussed it multiple times now. But you, as an energy major, how do you see, or how do you grab that opportunity? I mean, these 15 billion cannot be the reply alone, or is it that, or?
Oil as a product is not just going to stop. Isn't going to go away. Yes, we've made a lot of decisions in the past with that mindset. But I think it now has come to the point that we need to change significantly. It doesn't mean to say that almost everything around us, polyester clothing, any bits of plastic from the pen, it's generally come from a barrel of oil. Makeup, pharmaceuticals. We can't just stop all of that. We're also pretty efficient as ExxonMobil in our refining versus some others. I think we're about 15% more efficient. So we can't just stop that, because the world would be a worse off place. There's still demand for those products. So again, we do what we can do based on the skill sets, the assets that we have. But we are having to reconsider, look at new areas. This indeed, you can't just buy your way out. People have said, why don't you invest in solar? Why don't you invest in nuclear even as well? We've got a lot of experts that know the business very well. And would we be able to add value to that, as opposed to just buying and then, like I say, trying to buy your way in? If we can't really add value to it, let others do that, and let's try and focus where we can really add the value. So with the hydrogen going forward, we've got the expertise in that area. Now it's about scaling it up, making it more available in those areas which are extremely difficult to decarbonize. The power, the manufacturing side of things as well. And we can't be everything to everybody, either of, really. So our marine fuel footprint is about 60 ports. On the marine lube side, we're in 700 ports. There are other resellers that have a full global offering. We're just focusing where our strengths are, based on our sort of asset base as well. So there's no quick fix. This investment, to answer one of the other questions there, how far away are we from H2? These projects, even starting to put sort of bricks in place and the infrastructure in place to build these hydrogen hubs and CCS facilities, that's still a few years away. But then you've got to start somewhere. If we don't start now, we'll be waiting even longer. We'll be here again next year saying, hey, I think you said this last year, show us what progress has been made.
Okay, so if there is still some ship owner left, maybe we should invest into project cargo ships, because those guys are going to have to build huge infrastructure to produce all this hydrogen and this stuff, and obviously at locations which are not where the manufacturing of these goods is going to be, obviously. So
we are beginning to see a number of questions coming in here, and let's leave you for a while and go to Ms. Bryce. You know, there was this very clear question about the FAME blends, the various percentages. Do those different concentrations impact lubrication formulation?
So we know that the source of the biofuels does have an impact. So some of them are more resistant to the oxidative degradation than others. So yeah, source of biofuel is important when considering usage. But again, the levels of the renewable content is where we see the higher risk for marine applications. We saw those issues with automotive applications where the levels were less than 10%. So the risk we see is just elevated when we're looking at B30, B50 for the marine applications. So as I mentioned before, selecting a lubricant that has the improved oxidation characteristics and also the cleanliness performance would be a good match to mitigate against the risk of using biofuels.
Thank you. Clear answers here. Vatsala, over to you about test on 100% hydrogen. How
Yes.
far are you on that?
We have tested 100% hydrogen on a R&D single-cylinder engine and found out that it is an excellent way to destroy engine parts. It's an extremely nervous molecule, so keeping combustion stable is really a challenge. Our roadmap is based that in 2025 we have an engine concept ready that we can productize. So after that there will be a productization step. As I mentioned, that is based for the energy business. We could take the technology towards the maritime business as well, if the business case is there. But currently we are still very much at an R&D stage, and a lot of work still to be done before we have a concept, let alone an engine product ready.
So just out of curiosity, is that running your test the auto principle or the diesel principle? Side?
We are testing both there.
And they're both challenging?
Absolutely.
Thank you. Thank you very much. I think we are, and I think you did, Eddie, answer the question about, you know, how far we are in the H2 world. And actually, I think I saw an article, and I think it predates almost this millennium, by a professor from, I believe it was from MIT, who talked about, you know, this gradual change in energy use, where you went from coal to oil to gas, ended up with hydrogen, and actually significant to this, the what you say, relationship, or the ratio of carbon to hydrogen on these different fuels. We actually have been moving towards a hydrogen world for decades, and yeah, it's probably where we will end up if we can control the combustion process. I would like to thank the panel very much. It's the last panel of the day, and the other room should be finishing now, and rejoin us here in the main hall for a kind of roundup. Are the people here already? That's good. I think, yeah, people are coming in now. That's good. So thank you very much to the panel. Let's give them a round of applause.